Okay, so we have question 5. It says an object of mass 1.8 kg slides down a rough curved track and passes point A, which is 1.5 meter above the ground at a speed of 0.95 meters per second. The object reaches point B at the bottom of the track at a speed of 4 meters per second. 5.1 says define the term conservative force. What is that? So we say conservative force is the force for which the work done in moving an object between 2 points is independent of the path taken. Nice. Then 5.2 says name the conservative force acting on the object. So what is that one force that does not depend on the path taken here? Obviously, we know that's gravitational force. With gravitational force, we don't care whether the object is moving downward, upward, left or right. The gravitational force is always acting downward. Therefore, it does not depend on the path taken. 5.3 says is mechanical energy conserved as the object slides down from point A to point B? Choose from yes or no. Give a reason for the answer. So is the mechanical energy conserved? We say no. Why? Because there is friction, and friction is a non-conservative force. This means this is not an isolated system. As we can see here, we've been told that this slides down a rough curved track, right? So when there is friction involved, that means mechanical energy is not conserved. Remember, with mechanical energy, it has to be an isolated system, meaning there has to be no loss of energy. Then 5.4 says calculate the gravitational potential energy of the object when it was at point A, right? So to calculate the gravitational potential energy, we know the formula goes as EP is equals to mass times the gravitational acceleration and the height above the ground, right, or above our 0 point. Then the mass of the object is 1.8. And then our gravitational acceleration, it's a constant, 9.8. And then what is our height? That's 1.5. We are given there. Then 1.8 times 9.8, 1.8 times 9.8 times 1.5, that is 26.46 joules. Nice. So that for 3 marks. Then 5.5 says using energy principles, calculate the work done by friction on the object as it slides down from point A to point B. So now I'm going to use the WNC, as I've heard you say that why is it that I don't use this formula? So we can use this formula now because we know that there is a non-conservative force, which is friction. They told us this is moving down a rough curved track. So let's try to use the WNC formula and see if we can calculate the work done by friction. So we have work done by non-conservative force. The NC is for non-conservative, and then this is change in P, and then plus change in Q. Change in EK. Now you must always be careful with this formula. You only use it when you are sure that there are non-conservative forces there. Then this is the non-conservative force that we have is the friction, and then this one will break down as half m, and then this is Vf squared minus Vi squared, and then plus the change change in EK for this one, and then change in EP. So the change in EP, so remember kinetic is this, and then the potential will be mg, and then height finally minus height initial. Then work done by frictional force, that's what we're looking for. So we can just start substituting now. What is the mass? The mass is 1.8. And then what is our velocity finally? They say it reaches that point on the surface at a velocity of 4 meters per second. So that's 4 squared. And then remember, when it started up the slope, it was 0.95 and then square. Then plus, what is the mass? Again, it's 1.8. And then our gravitational acceleration, that's 9.8. And then what is the height finally? When it reaches the ground there, the height is 0. Relative to the ground, it's on the ground, so that's 0. But then when it was still above the ground, the height was 1.5. So it's just a matter of punching all this in your calculator. Then you have work done by friction is equals to negative 12.87 joules, right? So that becomes the work done by frictional force. Then okay, they say surface BC in the diagram above is frictionless. 5.6 says what is the value of the net work done on an object as it slides from point B to point C. So now we are told that it is frictionless. That means that BC is now an isolated system. So from point B to C, this is an isolated system. That means there are no frictional forces here. No frictional forces. As we are told, the surface is frictionless. So what is the value of the net work done? If we know that this is an isolated system, then the net work done there is 0 joules. So that for 1 mark, W net is equals to 0 joules. And you are done.